So as we know that there are two types of charges, that is positive charge and the negative charge, right? So positive and negative charges are there. So basically what happens, as we know that if we bring opposite charges, like opposite nature charges, they will attract towards each other, right? So definitely there will be some field around this charge, due to which what will happen, the other charge will attract towards the towards this charge, right? So definitely there will be any field, because of that it will be attracted. So the field around it, that we will be calling it as electric field. So what is electric field? It is a region around the charge. So if suppose this is a charge, so the region around this charge, we will be calling it as electric field, right? So to represent electric field, we actually use electric field lines. What we use? Electric field lines, right? So if it is a positive charge, then the field lines of a positive charge will always be radially outward, and if it is a negative charge, it will always be radially inward.
Yeah.
Okay, are you clear this much?
Yeah.
Okay. Now this is all about the charges, right? Now let's start with the just a second. Now let's talk about the current. I'll just rub this out. So now let's talk about the conductors, right? So what thing makes a conductor different from insulator? Free electrons. So if there are free electrons in the conductor, there are free electrons in the conductor, due to which it can conduct electricity, right? And in the insulators, we don't have free charges. So if we don't have free charges, if the electric current is due to the electrons only. If there are electrons, if electrons are moving in a certain direction, then only we will be having electric current. Otherwise, we will not have a current. So in insulators, we do have electrons, but they are not the free charges, right? They don't move in a single direction, and they don't have free charges. So due to which they actually don't conduct electricity, right? So I have taken a conductor, है ना? तो ये conductor है. मैं normally एक conductor की बात करूँ तो एक sorry. Do you understand Hindi?
Yeah.
Okay, then that's fine. So this is a conductor and it has electrons, right? So randomly, if we'll not apply any potential difference, or if we'll not apply any battery or any cell, the electrons are moving in random directions, right? They are moving in a zigzag direction, like here, like this, right? You don't know what is the direction. They are moving in a zigzag direction. As soon as you will be applying some battery or a cell, what will happen? The electron will start moving in a single direction. The electron will start moving in a single direction. So then it will conduct electricity. So basically, I have to tell you what is a current I. Current I tells us Q by T. What is Q by T? Q by T is actually telling us that, suppose I have taken a small cross-section area. Right? It's a small cross-section area I have taken. Suppose there is a conductor. Suppose this is a conductor, and I have taken the small cross-section area from here in the mid. Okay. So how many electrons are passing through this area in a unit time, right? That we will be calling it as electric current, right? How much charge, how much electrons is passing in a unit time through this cross-section area, that is the current. Basically, how fast electrons are moving in a particular in this area in a unit time, that we will be calling it as current. Now there are two types of current, like not two types, basically two types means it one is the average current and the another one is the instantaneous current. Okay, so this is the formula that we write it, that is for the average current, and generally we always find average current only. But what if we have to calculate instantaneous current? So do you have any idea about differentiation?
Yeah.
Like what is the difference? Yeah, differentiation, integration.
Yeah.
Okay, so if we have to find the instantaneous things, if you have heard instantaneous velocity, instantaneous acceleration, then what we do is we differentiate every time, right? So if I talk about instantaneous current, So in instantaneous current, what we will be doing is we will be writing dq by dt. dq by dt, that is telling us small change in small time, in a unit time, and actually we differentiate it, then we will be getting the current, instantaneous current.
Yeah.
Right? Okay. So far so clear?
Yeah, yeah.
Is everything making sense?
Yeah, it is.
Okay. Then what happens is, right now I talked about the charges. There are two types of charges. Second, I talked about the what is the current, and then I'm talking about the current direction. Like I will be talking about the current is a scalar quantity. It's not a vector quantity. I hope you are clear with the scalar and the vector thing. Like what is the scalar quantity and vector quantity. So suppose there are two wires in our house, not two, three. Suppose I1 current is passing from here, I2 is over here, and the net current is going in this direction. Okay, you can take any direction, like it's up to you. I have, for our easiness, I'm taking this method, right?
Yeah.
So basically what is happening over here is, suppose there are two current is passing through it. So if I have to find the net current over here is, so what I will be doing is, if I have to find the net current passing through at a point A, what I will be doing is I1 plus I2. Right? That's how you will be finding the electric current. You are not applying any vector addition. If any quantity is a vector quantity, for that what we will be doing is, if we have to add any two vectors, if we have to subtract any two vectors, in that case we will always be using vector addition, vector subtraction, or either we will be using parallelogram law of method and triangular law. Here we didn't use any part of it. Like we didn't use anything, like we didn't take any resultant or something. We just added them directly, right? If we added them directly, that means it is a scalar quantity. It is a scalar quantity. That means we didn't apply any angle theta, or we didn't say that take the resolution. Did we took like this, I cos theta, I sin theta? No, right? So that means it is a scalar quantity, right? Cos theta and sin theta, if you remember, if any vector quantity is at any angle theta, we take the we resolve this, suppose this is any vector, we resolve in two components. If you remember, a cos theta and a sin theta, right? Do you know that?
Yeah.
Right? So we didn't do anything here, right? So that means it is not a vector quantity. So if it is not a vector quantity, that means the current is a scalar quantity, right? So far so clear?
Yeah.
Okay. Now if I talk about what is 1 ampere, what is 1 ampere?
It's like current that passes through one like unit of time.
Very good. 1 coulomb charge is passing in 1 unit time, 1 second, in 1 second. That is 1 ampere, right? Ampere is the unit of current, and coulomb is the unit of charge.
Yeah.
Right? And time we measure in seconds. That is what it is. Okay. Now I hope you are all clear with this. Any questions?
No.
Okay. Okay. Now we talked about this. Now let's talk about the what is the flow of the electrons in a circuit, right? So suppose this is a conductor. If I apply the potential difference across it, this is a positive terminal and this is the negative terminal. Suppose these are the electric charges, and electric field direction is always positive to negative. Right? Electric field direction. Okay.
Yeah.
So what is happening over here is, there is a conductor, and a conductor, we have applied the potential difference across the conductor. So what will happen over here is, electric field will be generated from here to here.